Hello, sir. Hello. Hello. Okay. Yeah, I'm starting. So, very good afternoon to all our students who are logged in this live virtual class. I first wish you a very happy CA day. I am CA Arijit Chakravarti from Kolkata. I wish you a very happy CA day. Let us learn mathematics and statistics with fun. Let us interact and let's get prepared for our exams. Please raise queries relating to the subject only as and when we discuss each and every chapter. Today is my first session with you and this is being devoted. This topic will be equations. First and foremost, friends, I will discuss, since it's the first session with you, I will first discuss a little bit about your exam strategies. Then I shall be discussing about recapitulation of certain algebraic equations, which will be helpful for you to understand this chapter on equations. Then we shall cover the different types of equations. In fact, there are multiple types of equations. We have linear equations, we have quadratic equations in our syllabus, and there is cubic equation also. Plus, we will do number of problems on linear equations. Quadratic equations we will cover, the most important formula in quadratic equation, how to find the roots, etc. And then we will move into cubic equations and we will cover number of problems on equations and we will try to solve it together. So this is going to be the discussion point for today's session. I hope the audio and video is coming fine and you are all logged in, and let us get started with the introduction. Now you may think why mathematics and statistics and logical reasoning is included in our curriculum. Dear students, these subjects actually strengthen your conceptual base to become a successful chartered accountant. You have an economics paper in foundation. There also we learn a lot about different types of, economic principles. We learn about using GDP. We understand about GDP, percentage change, and there is a direct application of ratios and percentages. In financial statement analysis, you are learning about balance sheet, profit and loss statement, cash flow statement. Even in financial statement analysis, we use a lot of mathematics. Friends, when you move to IPCC, you will be studying audit paper, and in audit, you will also learn something called sampling, and sampling is something we learn in statistics. Therefore, throughout your journey in CA, right from foundation, IPCC and final, the entire world of financial management, risk management, which you are going to study in the days to come, is based on mathematics, statistics and logical reasoning. So this is the reason why this paper is included in foundation. It's a very, very scoring paper, and I will also tell you that many of you might be coming from science backgrounds, many of you might be coming from commerce backgrounds, but you all know, you read long back in your school, something called Newton's laws of motion. If you remember, there are 3 laws of motion, and in one of the laws of motion, Newton says that to every action, there is an equal and opposite reaction. Now, friends, if you look at the world of accounts, so you see the world of science, the world of mathematics says that to every action there is an equal and opposite reaction. And if you now see what is there in accounts, we learn to every debit there is an equal and opposite credit. So dear friends, finance, accounts, mathematics, science are all the same. The principles are the same. The logic is the same. Only the use of tools and principles possibly are a little different. Now, dear friends, since this is a very scoring paper and I shall be taking number of chapters in your mathematics and statistics paper, first and foremost, being the first day with you, I would request you to prepare a timetable for your November exams. Please start early. Do not delay your preparation. Please do not defer your preparation. Please start immediately. Now it is July. You have almost 3-4 months left. So please start immediately. Follow the institute's study materials, institute's practice manual, scanner, etc. Be very, very careful and follow the live virtual classes religiously. Try to take notes and always go through the presentations which we are going to share in course of the live virtual classes. And please remember, this paper, mathematics, statistics, and logical reasoning, is a very scoring paper. If you answer the questions correctly, then there is no way to lose marks. So if you get high marks in this paper, your overall score in business mathematics and statistics will go up, and your overall percentage of success in the CA Foundation exam will go up. So please take this paper very, very seriously. And also, during the live virtual classes, whenever possible, if you have a doubt about any specific chapter of the syllabus which we are covering related to the subject, please raise the doubts. You have a platform where you can share your doubts, your questions, and I shall be trying my best to come back to you with an answer, with a response, with a solution. And dear friends, please study all chapters of your business mathematics and statistics and logical reasoning paper, that is paper 3, because you never know, the questions usually come from all parts of the syllabus. So please do not go for any type of, I would say, suggestive preparation. Please cover the full syllabus. Don't go for any selective type of preparation. Try to cover the entire syllabus. And please also, another important strategy is that kindly prepare your own revision notes. You have the CA model test papers, practical problems. We are going to solve number of numerical problems on each and every chapter. And hello? Hello, yes? Okay, okay. Okay, I'm removing the headphone. Okay, okay. Hello? Hello? Yes. Just come. Yeah, am I audible, sir? Yeah, I'm just... Yes. I hope it is coming. Yes. Okay. Right. Request. Yeah, it is coming. Yes. Okay. So, yeah. So my request to the students is that please try to prepare exams, numericals under exam conditions. And today we are taking up the first session, and this is on the linear equations and quadratic and cubic equations. Next day, we shall take up the matrix and other miscellaneous problems on equations. Now, first and foremost, I am writing few important formula which are important from revision perspective, because an equation is nothing but a mathematical statement of equality. So we will go back and note very important equations which we had learned way back in school, and it's going to be very effective for us now in this particular chapter. So a plus b square, you may remember, dear students, the expression a plus b whole square it is a square plus b square plus 2ab. First equation to remember. The second equation is a minus b whole square, and this gives us a square plus b square minus 2ab. So these two equations are very important as revision. And the third equation is a plus b into a minus b, which gives us a square minus b square. So these three equations are very important. A plus b whole square, a plus b whole square, a minus b whole square, and a plus b into a minus b. I am sure you remember these, and these are just a revision before we enter into equations. Also, please remember the cubic formula a plus b whole cube, because that is important and that is going to be helpful when you move into some of the problems in this particular chapter. Now in equation, if you see, since we are taking up equations today, and equations, we have three types of equations, of course. We have linear equations, we have quadratic equations, and we have cubic equations. Now there are a number of solutions to it. So first is the linear equation, then we have quadratic, and then we have cubic equations. So three types of equations are there. Today we are going to complete and discuss linear, quadratic, as well as cubic. So first and foremost, what is an equation? Now it is a mathematical statement of equality, and please remember that when we talk of equation, we also talk of another term which is called identity. Now if a relation is equal only for one value of x, then we call it, of course, an equation. But if it is valid for all values of x, then it becomes something called an identity. I will give an example. So I'm writing something. Please see this equation. X plus 2 by 3 plus x plus 3 by 2. Now this is equal to 3. This particular expression, is it an equation or is it an identity? Now if you see clearly, you will find x plus 2 by 3 plus x plus 3 by 2 equals 3. Now this is going to hold good only when x is equal to 1. So when x is equal to 1, then this particular equation will be valid. So this is an example of an equation. Why? Because this expression, the left hand side and the right hand side, will balance only when x is equal to 1. But if you have this equation, x plus 2 by 3 plus x plus 3 by 2, if I write on the right hand side 5x plus 13 divided by 6. So now let us see this once again. On the left hand side we have x plus 2 by 3 plus x plus 3 by 2. On the right hand side we have 5x plus 13 by 6. Dear friends, this, if you see, it's going to hold good for all values of x. So you can see that ultimately when we talk of equation, if the equality is true for all values of variable, then we call it an identity. So in this case, this is an example of identity because ultimately it holds good for all values of x. Okay, now let us see a very interesting case, a very interesting question on equations. Equation means there is a left hand side, there is a right hand side, but I am asking a very interesting point. Friends, can we prove 1 is equal to 2? Can we prove 1 is equal to 2? Very interesting. Mathematically, can we prove this? Let us see. So, I am taking use of a simple formula which I was explaining 2-3 minutes back, and that was a plus b into a minus b, which gives us a square minus b square. So let us take this example. Okay. So let a equal to 1. A is equal to 1. Therefore, we can write a square is also equal to 1, because a square is a multiplied by a. You have already done indices. So a multiplied by a is also equal to 1. So a is 1, a square is also equal to 1. So we can write, if both are 1, we can write a square is equal to a. So a is equal to 1, a square is equal to 1. So we can write a square is equal to a. Now if you deduct 1 from both the sides, what do you get? You get a square minus 1 is equal to a minus 1. Now left hand side a square minus 1, right hand side a minus 1. But please see, the left hand side is a square minus 1. This is of the form a square minus b square. Because a square minus 1 actually means a square minus 1 square. So this is of the form a square minus b square, and what we get is a square minus b square. If you break it up, if you split the expression, you get a plus b into a minus b. That means a square minus 1 is actually equal to what? It is equal to a plus 1 into a minus 1. This is the left hand side, and the right hand side of course was a minus 1. Now if you cancel a minus 1 from both the sides, what do you get? You get a plus 1 is equal to 1. But friends, we had assumed we had said that a is assumed to be 1. Since a is 1, on the left hand side you have 1 plus 1, which is 2, and on the right hand side you have 1. Therefore 2 is equal to 1. But is this correct? Can you really, even though we are proving it, but is this correct? Answer is no, this is not correct. Why this is not correct? Because we have cancelled a minus 1 both on the left hand side and again on the right hand side, and a minus 1, if you see, what is the value of a minus 1? A is 1. So a minus 1 is 1 minus 1. We have taken a as 1. So a minus 1 value becomes 1 minus 1, which is 0. And we know cancellation by 0 is not allowed in mathematics. That is why this funny result is coming, that 2 is equal to 1. Similarly, using this method, you can prove 2 is equal to 1, 3 is equal to 1, 4 is equal to 1, any number. But definitely it is not true. If you have 2 chocolates, does it mean, and if I have 1 chocolate, it cannot be the same. You have more than me, so it can never be equal. So you can see it's very interesting, but we also need to know the problem, because the problem was that I was dividing both the sides by 0, which is not allowed in mathematics. Okay, now let's move on to the types of equations. So first we are discussing linear equations. Now what is linear? So let us talk about linear equations. Now linear equations, linear, and then we will see quadratic. If I write the equation, say for example 8x plus 17 into x minus 3 equals 4 into 4x minus 9 plus 12. So please see that in this expression 8x plus 17 into x minus 3 equals 4 multiplied by 4x minus 9 plus 12. In this expression, if you see, the power of x is 1. Now you have already done possibly the chapter on index number or indices. So you know that x actually means x to the power 1. So when x has a power of 1, x to the power 1, we say that it is a linear equation. The word linear means line, straight line, straight line. Linear is line. So if you plot, you remember in school we used to use graph papers for plotting in geometry class, you may remember, long back. So if you see in this particular case, linear equation, it will have a straight line. So x and y will be something like this. Maybe the line is like this. Straight line. So this is linear equation where x has the power 1. But the moment, let's go to quadratic. Now the moment when I write, say for example, 3x square plus 5x plus 6 is equal to 0. Okay, this equation, 3x square plus 5x plus 6 is equal to 0. This, friends, this becomes a quadratic equation. Why? Because we have x, the power of x, if you see, is 2. So I am highlighting this. The power of x is 2. X square. So x into x. So this is quadratic. The second type. So first is linear. The second is quadratic. And now let us see another example of equation. Let us write this one. Cubic. So in case of cubic equation, I am writing 4x cubed plus 3x square plus x minus 7 equal to 0. So it is 4x cubed plus 3x square plus x minus 7 equals 0. Now this is an example of cubic. Why it is cubic? Because x has the power 3. X is having the power or the index. You know, dear friends, the word power is also called index in mathematics. So here in linear equation, x has the power of 1, x to the power 1. In the case of quadratic equation, x is having the power 2. X means the variable. It can be y, it can be a, b, whatever. But the variable here has the power 2. And in case of cubic, it has the power 3. Right? So there are 3 types of equations. We have linear equations, of course. We have quadratic equations. We are having cubic equations. Now, in every case, we have seen that we are talking about x. But this means only one is unknown. X is unknown. We don't know the value of x. So we have one equation for one unknown, and that is x in this example. Now, what will happen when we have 2 variables? So I am writing one equation now. So this 3 we have understood. We now go to another type of equation. I am writing this. So if I write x plus 2y, x plus 2y is equal to 1 and 2x plus 3y equal to 2. So we are having 2 equations. X plus 2y is equal to 1 and 2x plus 3y is equal to 2. So this, please see, we are having 2 variables, 2 unknowns. We don't know the value. X, we don't know the value. Y, we don't know the value. So 2 unknowns, which means these are examples of simultaneous equations. So these are called simultaneous equations. And we will solve these equations today itself. So friends, till now we have seen the types of equations. I was talking about linear equation which has a straight line nature. We talked about quadratic equation where the degree of x becomes 2. We also saw what is called cubic equation where the degree becomes 3. And now if you have two types of equation, two unknowns, we have x and we have y. So I am underlining x and y, two equations, two unknowns. So these are simultaneous equations. Similarly, we can have z also, x, y, z, three unknowns, three variables. But for that, we need three equations. For one unknown, one equation is required. For two unknowns, if you want to find out the value of two unknown figures, x and y, you need two equations, two simultaneous equations. And if you have three unknowns, x, y, z, then you should have three equations so that you can find out the value of x, y, and z from three simultaneous equations. I hope you are following and you are able to understand. Now, let us do a small example. Example number 1. So please try to do this example with me. Let us solve it. So minus 7x plus 1 is equal to 5 minus 3x. So let us try to solve this. Minus 7x plus 1 is equal to 5 minus 3x. How to solve this? Please see that it is a linear equation because x has the power 1, x to the power 1. So we have a linear equation, straight line. And we have one unknown. So let us solve it. So let us bring in these type of questions, dear friends, we have to bring x to one side. All the unknowns, all the variables has to be brought to left hand side and all the numbers have to be transferred to the right hand side. So you can balance, right? So left hand side all the unknowns and right hand side will be all the value. So in this case, if you bring this 3x to this side, left hand side, we are getting minus 7x. This minus 3x. So when you shift to the left hand side, from the right hand side, when you shift it to the left, the sign will change. So this minus now will become plus. So minus 7x plus 3x. Okay, this is the left hand side. On the right hand side, so we had 5. So I'm writing 5. And we had 1 on the left hand side. This will now go to the right hand side. So we will get 5 minus 1. So we had a plus sign, this becomes minus sign, right? So let us see, this gives us minus 7x plus 3x. How much is that? Minus 7x plus 3x is minus 4x. And on the right hand side, we have 5 minus 1, which is 4. So minus 4x is 4. So I can write 4x. I'm changing the sign now. I'm changing the sign from minus to plus. I'm writing minus 4x is 4. So 4x is equal to minus 4. Minus 4. The sign changes. Therefore, x is equal to minus 1. X equals minus 1. So dear friends, what have we done in this simple type of equation? Minus 7x plus 1 is equal to 5 minus 3x. This is the problem which is given to us. Step number 1, we have brought all the x factors, with the terms which has x, we brought it to one side. So we have minus 7x plus 3x. We brought this 3x to the left hand side. And on the right hand side, we are having only the numbers, only the absolute value, only the absolute numbers. And the absolute number is 5 and 1. So already we had 5. Now plus 1, which we had on the left hand side, we are transferring it to the right hand side. So there's a sign change. So we have got minus 4x is equal to 4.
by transposing the sign, by changing the sign, we have 4x equals minus 4, which means x is equal to minus 1. This is the solution to this problem. This is problem number 1. Now we move on to problem number 2. Problem number 2. I hope you are following. I hope you are understanding the type of equations which we are going to deal with. We have already discussed about linear equation. We have seen the type of quadratic equation where the power is 2, and we have seen cubic equation where the power is 3. So now let us take up example number 2, problem number 2. Now the problem is very simple. X by 30 is equal to 2 by 45. So what is the value of x? So this is a linear question. You can see it has the degree 1. So it's very simple. So here, just by multiplying, cross multiplying, you know the diagonal rule, the cross multiplication, it becomes cross multiplying. So 45x, 45 into x, because we have x by 30 equal to 2 by 45. So the numerator on the left hand side, we are multiplying it with the denominator on the right hand side. So we have 45x equals 30 into 2. So it is 60. Right? So therefore we can easily find out the value of x from here. X is equal to 45x is 60 equal to 60 by 45. So this comes to 4 by 3. Because you can divide it by 15, so it is 4 by 3, that is 1 whole 1/3. Right? So this is an example of a simple equation, and I hope slowly we are going into more bigger ones, complicated ones, and I hope you are able to follow, understand. We are going very slowly so that each and every point is clear in our mind and we slowly understand the beauty of mathematics, the beauty of equations. It is so very beautiful. You will see more of it as we go along. Now we move on to the third example. So we have already seen 2 examples. Now we move to the third example. What do we have in the third example? Okay, let us do it together. So we are taking a simultaneous equation. Dear friends, little while back I was discussing that we have 2 types of equations. We can have equations with one variable. It can be a linear equation. It can be a quadratic equation. And we can also have simultaneous equation. What is a simultaneous equation? An equation which has 2 unknowns, 3 unknowns, 4 unknowns, and so on. So our example number 3. So I'm writing example number 3. We have already done 2 examples. Number 3. 2x plus 5y is equal to 9. 2x plus 5y equal to 9. This is the first equation. And 3x minus y is equal to 5. This is the second equation. So 2x plus 5y equals 9 and 3x minus y is equal to 5. So when we have these type of equations, the idea is you have 2 equations. So the idea is to eliminate one of the variable. How do we do it? Now you can see that here we are having 2x plus 5y equals 9, 2x and 5y. Here we have 3x and minus y. Now if I multiply the first equation by 3, I'm writing in red color so that you can understand. So if I multiply the first equation by 3, what do I get? Let us see. So 3 into 2x. So we are getting 6x plus 3 into 5 is 15. 15y. This is equal to 3 into 9 right hand side, which is 27. This becomes our new equation. And this is equation number 1. Okay? Fine. Now let us do one thing. Equation number 2 we have 3x minus y is equal to 5. Let us multiply this equation by 2. So let us multiply this by 2. So what do we get? 2 into 3x, that is 6x. So again I am writing 6x minus, this minus comes down, 2 into y, so 2y is equal to 2 into 5, which is 10. So this becomes our new equation number 2. So dear friends, in this example, till now, what have we done? We had a simultaneous equation involving x and y. So two equations are given, two unknowns are given. So we have multiplied equation 1 by 3 so that we can get this 6x. Similarly, we have multiplied equation number 2 by 2 so that again we get 6x. And now what happens is, once we have these two equations, what we do is, very easy, if you just subtract equation number 2 from 1, 6x is gone, is cancelled out. So you are having 15y and 2y. So we are subtracting 2 from 1. So 6x minus 6x is 0. And 15y minus of minus 2y. Please note that we have a minus sign here. We have a negative sign here. So 15 minus of minus 2y. 15 minus minus 2 gives us 15 plus 2. Because we know minus and minus becomes plus. So we have 15 and 2. This becomes 17y. And on the right hand side we have 27 minus 10, which gives us 17. So dear friends, we have got 17y is equal to 17. Therefore, y is equal to how much? Y is 17 by 17, which is 1. So we have got the value y is equal to 1. Now if you know y is equal to 1, so now we are going to put y equal to 1 in this equation, the first equation. In the first equation, we are going to put this. So what we are going to get? Y equal to 1. So we will write 3x minus 1 equal to 5. 3x minus 1 is equal to 5. Which means I have substituted the value of y with 1. Because already y equal to 1 we have found out. We have worked out. Therefore, 3x minus 1 is equal to 5, which means that 3x is equal to 5 plus 1 is 6. So x is equal to 2. So dear friends, in this example, this is example number 3, we have seen that when we are getting a simultaneous equation, we are having two numbers, two unknowns and two equations. We are trying to knock off, remove, eliminate one variable. So since I saw that we have 2x and 3x, the LCM of 2 and 3 is 6. So I used 3 into 2, equation number 1, what we had 2x plus 5y, I multiplied that by 3 and I multiplied equation number 2 by 2. So that we get 6x and we can cancel 6x, we can cancel the x factor, we will have y, and we were able to work out y comes to 1 and x, by substituting the value of y in this equation, x comes to 2. So I hope this is clear to you. This is a simultaneous equation, example number 3. Now we shall move on to the next example. We will work it together. I request all the students who are logged in to kindly work with me step by step so that we can understand each and every part of this particular chapter. Now we are taking up example number 4. So I am writing example number 4. Example number 4. Well, let us see this example. So we have 3x plus 2y plus 17 equal to 0. So let us see the equation. It is a equation with two variables, 3x plus 2y plus 17 equals to 0. And the second equation is 5x minus 6y minus 9 is equal to 0. Okay, so here again, if you see, we are having two equations, two unknowns. So x is unknown, y is unknown. So equation number 1, this is 1 and this is 2. So what can we do from here? Let us try the method of elimination, substitution, which I was using in the last example. So you will be finding it easy, and I request you to do it with me. The more you do mathematics practically, the more your accuracy will go up. You will have interest in the subject and your score in the exams will shoot up. So please do the practice with me, and please have pen and paper with you so that you can work out the problems along with me. Let us learn together and make it as interactive and productive as possible. So in this example, let us do one thing. First, let us bring x and y on the left hand side and the value on the right hand side. So what we do is we just try to multiply. We first bring 3x plus 2y equal to, this will become minus 17. So we make it minus 17. And the next equation, if you see, 5x minus 6y, so I'm writing 5x minus 6y. We have minus 9 on the left hand side. When it moves to the right, on the other side of the equal sign, it will become plus 9. Minus 9 to plus 9. So it becomes 9, plus 9, right? So the equations are 3x plus 2y equals minus 17. 5x minus 6y is equal to 9. Okay. So in this case, we try to knock out y. Okay. In the last example, I was using multiplication to knock out x. This time, we are targeting y. So you see, please try to see this equation, very interesting point. 3x plus 2y is minus 17 and 5x minus 6y is 9. Please see that the y, the coefficient of y is 2 and 6. So what to do? How to knock out y? How do we eliminate y? How do we remove y? Very simple. We will multiply equation 1, this equation, with 3. We will multiply it by 3. The moment we multiply equation 1 by 3, let us see what do we get. What are we getting? 3x into 3. This gives us 9x plus 2y. 2y plus 2y into 3 gives us 6y. And we are multiplying this by 3. So on the right hand side, we have minus 17. We multiply that by 3, so we get minus 51. Minus 17 into 3. This is minus 51. Okay, so this is the new equation, right? And already we had the old equation number 2. 5x minus 6y. So I'm writing here 5x minus 6y is equal to 9. So if you see now, friends, this part, right, I hope it is clearly visible. 9x plus 6y equal to minus 51. And then we have 5x minus 6y is 9. So we have plus 6y and minus 6y. We just add. We add up these two. We add up. So if you add it up, what do you get? 9x plus 5x gives us 14x. 6y plus minus 6y. So this is eliminated. And on the right hand side, we have minus 51 plus 9. Minus 51 plus 9. so you get minus 42. If you get minus 42, so 14x equal to minus 42. So x is how much? If 14x is minus 42, then x is equal to minus 42 by 14, which is minus 3. So we have got the value of x by elimination. X is equal to minus 3. So what to do next? You have to find the value of y. How would you find the value of y? Simply by substitution. So let us go back to the original example. The equations we had. X is equal to minus 3. Now we put this in this equation. So we are having 3 into minus 3. So 3 into minus 3 plus 2y plus 17 equal to 0. 3 into 3 is minus 9. So if you transpose, if you remove whatever was there, I'm just rubbing this part out so that it's easy for you to understand. So the equation was 3x plus 2y plus 17 equal to 0. I have put the value of x. Now x has come to minus 3. I am putting that value here. So I am getting 3 into minus 3, which is minus 9, plus 2y plus 17 is equal to 0. Now it is simple. One equation, one unknown. Very simple. So 2y is equal to, this minus will come to the right hand side. It will become plus, and this 17 which you have, positive 17, on the other side, when we move it to the right hand side, it will become minus 17. So it becomes 9 minus 17, which is minus 8. So therefore, 2y is equal to minus 8. So y is equal to minus 4. So dear friends, the solution to this exercise, this particular example number 4 is x is equal to minus 3 and y is equal to minus 4. So I hope you are able to see this, understand, and now you are definitely getting some clarity of equations, how to solve the equations. I am requesting you again and again, try to do it with me so that you are able to clarify yourself and get more confidence in handling equations. Okay, now let's go to another interesting example, and this is a classic case where we are going to take 3 equations. So dear friends, slowly we are going a step higher, one by one, step by step, and now we will take 3 equations. We started with 1 equation, then we had 2 equations, x and y. Now we will move into 3 equations, x, y, z. So this is example number 5, I think. Okay. So we have to find the value of x, y, and z. We don't know, question mark. Let's see the equation. xy by x plus y is equal to 70. This is equation number 1. Next one, xz divided by x plus z. This is equal to 84. This is equation number 2. And the last equation is yz divided by y plus z is equal to 140. This is equation number 3. Okay. So I request you to please note the equations once again. Please note it. Okay, please. Let's note it once again. xy divided by x plus y is equal to 70. First, this is equation number 1. The next equation is xz divided by x plus z equal to 84. Okay, and the third one is yz divided by y plus z is equal to 140. So we are having 3 equations, 3 unknowns. So dear friends, this is a very interesting, one of the best examples. You will really love it. So 3 equations, 3 unknowns. See, as a chartered accountant, as a professional, you have to use your mind. You have to think out of the box. You have to use intelligence. Now, in this particular example, this is an intelligent question, an intelligent set of equations. So what we do, friends, we invert all the equations. Invert. Invert means from here down. Okay, down, invert. Okay, so this is red is at the top. I invert. So now red is down. Okay, so what we do is we invert each of the equations, and I'm writing the inverted equation with blue color. Okay, so what I do is first equation I invert. What will happen? If you invert an equation, dear friends, you have to invert the left hand side. You also have to invert the right hand side. Okay, so we are inverting it. So we are getting x plus y. That is the numerator. The denominator will now become the numerator. X plus y by xy. Okay, this is equal to 70. If you invert 70, you get 1 by 70. So it becomes 1 by 70. Okay, now the next equation, xz by x plus z. What will happen to this? So it will become x plus z by xz is equal to 84. We invert. So we get 1 by 84. Please do with me, step by step, 1 by 84. And the third equation is yz divided by y plus z is equal to 140. We invert it. So we will get y plus z by yz is equal to 1 divided by 140. Okay. So in this step, what we have done, we have inverted each of the equations. Why have we done it? Is there a purpose? Yes, there is a purpose. There is a reason why I have inverted. Now we shall see how this inverting helps us in solving this equation with 3 unknowns, 3 equations. Okay, so I'm rubbing. We will just note this blue part. I'm keeping the blue part. And let us just write this here. So we had x plus y by xy equal to 1 by 70. Okay, I'm rubbing now this part. Okay, first equation. Then we had x plus z by xz equal to 1 by 84. I am rubbing this blue part now. And then we had y plus z by yz equal to 1 by 140. Again, I am rubbing this blue part. Okay? Okay, fine. I hope you are following. Right. Now, let us see this particular case. This is one of the best suited problems for our practice in CA Foundation preparation for the exam. Now, x plus y by xy, if you break it up, if you split, you get x by xy plus y by xy equal to 1 by 70. And now, if you deduct x and x, y and y, what do you get? You simply get 1 by y plus 1 by x equal to 1 by 70. Please see. The second equation. In a similar way, if you split, if you break it up, what do you get? You get, similarly, you get 1 by z plus 1 by x is equal to 1 by 84. And similarly, if you break the third equation, you get 1 by z plus 1 by y is equal to 1 by 140. Right? Now, what we do, this is one of the toughest equation, but a very interesting one. Now what we do, we add up all of them. So if you add up all of them, what do you get? I'm writing it here on this side. Okay, so if you add up all of them, you have this plus this plus this. Okay, so on the left hand side, what are we getting? On the left hand side, left, what are we getting? 1 plus y plus 1 plus x, again 1 by z plus 1 plus x, again 1 by z plus 1 plus y. So each term x, y and z are coming 2 times, right? So we are getting 2 multiplied by 1 plus x plus 1 by y plus 1 by z. This is what we are getting on the left hand side. Is equal to what? Yes, left hand side 1 by 70 plus 1 by 84 plus 1 by 140. Okay. So, let us simplify the right hand side. 70, 84, 140. We have to find the LCM. So, it comes to 420. So, we take the LCM. 7 goes 6 times 6 plus 84, 5 and 143. So, it is 6 and 5, 11. 11 and 3 is 14. 14 by 420. This is 1 by 30 if you simplify. So, we have got 2 multiplied by all this. 1 plus a 1 by x plus 1 by y plus 1 by z gives you 1 by 30. So therefore, only this part, 1 plus x, 1 by x plus 1 by y plus 1 by z will give you what? 2 multiplied by this gives you 1 by 30. So only this part is equal to how much? 2 will come to the denominator this side, so it will become 1 by 60. That means, if I rub it out, I hope you have understood this step. That means 1 by x, okay, 1 by x plus 1 by y plus 1 by z is equal to 1 by 60. This is a new equation we got. But please see, already we had 1 by x plus 1 by y is 1 by 70. So if you put this here, you can easily find out 1 by z, x and y is here, x and y is here. So 1 by z is equal to 1 by 60 minus 1 by 70. From here you can find the value of z. I'm not working it out. It will take more, space and time. So in this way you can find out the value of z. If you find the value of z using the same principle for other equation, x and z, you can easily get the value of x and similarly for y. So in this example, what we did was we first inverted the equations, number 1. Then we split the equations. Then we added it all together. From there, what we did was we substituted it and we were able to find out each of the values, x, y and z. So this is otherwise a very complicated question, but in this way we can simplify. Now in mathematics, dear friends, we always try to simplify complex, long, complicated problems into simple, manageable portions. Okay, now we move on to quadratic. So that was all for the simple, the linear equation. Now we move on to quadratic. Okay, I hope you are following, and we have done 5 examples in linear part, linear equation. We have done 5 examples and we have worked the examples, each and every problem. Now we go to quadratic. Now quadratic equation has a form, has a particular form. You can see and understand. You can just see and understand that yes, it's a quadratic equation, right? So if you see the form of quadratic, the form, I'm writing form, right? What is the form? The form is ax square plus bx plus c equal to 0. Okay. So this is the form of a quadratic equation. Ax square plus bx plus c equals 0. And please remember that x is a variable here. And what are the constants? The constants are a, b and c. Okay, these are the constants. X is the variable, but please see that x has a power 2. X has index 2. Okay, so we have 3 constants, a, b and c, and we have one variable x. Okay, so when we have b, if b equal to 0, when b is 0, this equation is known as a pure quadratic. If b equal to 0, then this equation becomes ax square plus c is 0, right? So it's called a pure quadratic equation. And if b is not equal to 0, then we call this equation as an affected quadratic equation, right? So this is the form of a quadratic equation ax square plus bx plus c, where x is the variable and a, b and c are constants, and when b equal to 0, we call the equation a pure quadratic equation, and when b is not equal to 0, we call it an affected quadratic equation. Now friends, if you solve this equation, there is a long process, very long process, but that process is outside our syllabus for our CA foundation. So if you solve this, what do you get? Okay, I'm writing here. You have to remember, I request all the students who are logged in, or the students who are going to view this lecture, this session later, please try to remember this, because you will get a question on equations in your exam. It can be a linear equation, it can be a quadratic, it can be a cubic equation, but I'm sure a question will come in the CA Foundation exam on equations. So you must remember, and this solution x, the root x will be equal to minus b plus minus square root of b square minus 4ac by 2a. Looks very cumbersome, looks very puzzling. Yes? Okay, so but we break it up, right? Don't worry. This looks a bit cumbersome, but it's not that.
Yes,
not
sir.
that
Yes, sir.
difficult.
It is quite interesting here. Quite interesting discussion here, sir. Using
Yes,
this,
sir.
we can find out some of the roots and the products of the roots also.
Yes, sir. I'm coming to that. Sir, you are listening?
Yes.
Right.
Yes.
Okay.
I am also a student of you.
Okay.
Yes,
So
sir.
now, if you see, dear friends, since we are having this particular form, ax square plus bx plus c equal to 0. Now this looks very cumbersome, but please note that since it's a quadratic equation, there will be two roots. Now, roots. Now, say we will call it alpha and beta. So there are two roots. We will call it alpha and beta, right? So it will have two solutions. Now, one of the solution is minus b plus. So we take the upper one, the upper sign, minus b plus square root of b square minus 4ac divided by 2a. And the other root will be the lower one. So minus b minus square root of b square minus 4ac by 2a. So we are getting two roots, and therefore this will give us two values. Now, very important point which comes in the exam almost every time is a question which is based on the roots of the equation. Right, the roots of the equation. This will have two roots. Quadratic power is 2. So we will have two roots. Now let us see what the roots are, and let us add up the roots. We will get some new relation. Okay. So I am adding up, and let us do it together. So I said that one of the root, let's call it alpha. This is equal to minus b plus b square minus 4ac by 2a, and the other one is beta. So I'm taking beta here. This will become minus b minus, sign changes, b square minus 4ac by 2a. Okay, now if I add up, we are trying to find the relation of the two roots if you add it up. So if I do alpha plus beta, we add up. This right hand side also will be added. So this plus this, what do we get? So you can easily see, dear friends, that this minus b and minus b will remain. So in the numerator, left hand side we have alpha plus beta. On the right hand side we will get minus b, but this expression plus square root of b square minus 4ac and here minus b square minus 4ac. These two will be eliminated, cancelled. So cancelled. Gone. These are gone. So in the numerator it is simple. We get minus b and in the denominator we have 2a. This 2a comes down. So the relation becomes alpha plus beta is equal to minus b, that is minus 2b by 2a. If you cancel 2 and 2, you get a very, very important relation. Number one relation, a very important part of quadratic equation, which we cannot forget under any circumstances for our exam purpose, and that is alpha plus beta is equal to minus b by a. Very, very important relation. Very important. I will request the students who are going to view this lecture later on or who are logged in, kindly keep a note of this. That's why I worked it out so that you can see that the expression looks big. The expression looks very long, but don't forget that it can be broken down into easier parts, and we have got a very simple relation, alpha plus beta equal to minus b by a. This b and this a. Now we will try to see, okay, if the sum of the roots, that is alpha and beta, gives me minus b by a, what will happen if you multiply? What will happen if you multiply the two roots? Let us see. Okay, so we will work it out. So we are now going to work it out. We know that alpha is equal to minus b plus b square minus 4ac by 2a, and we know beta is equal to minus b minus, so plus and minus, b square minus 4ac by 2a. We will multiply. So we are going for multiplication. Left hand side, yes, we multiply. Alpha beta, it becomes alpha into beta, that is alpha beta. What will happen on the right hand side? So dear friends, let's try and see what happens. So we have minus b. We are first concentrating on the numerator. Denominator is easy. You have 2a and 2a. So it will become 4a square. The denominator part is easy. Let us focus on the numerator. So in the numerator we have minus b plus square root of b square minus 4ac, and again we have minus b minus square root of b square minus 4ac. Friends, this is of the form a plus b, a minus b, and in the beginning of the session today, when I was doing a recap, I was explaining this formula, a plus b whole square, a minus b whole square, and another formula, a square minus b square, that is equal to a plus b into a minus b. So here we are having, this is a plus b, a minus b. So if you multiply, you will get minus b square, a plus b into a minus b. So this is equal to a square minus b square. So minus and this square. So this square will be, if you remove this, it's a square root. So if you square it, the square root sign will disappear. You will get very simple, no square root sign. You will get b square minus 4ac. Fine. So now if you simplify this, you have minus b square minus b to the power 2. So this gives you straight away b square, because we know plus b into plus b is b square, minus b into minus b is b square also. So you have b square minus, within bracket you have b square plus 4ac, because now I am removing the bracket. So this becomes 4ac, and in the denominator you already have 4a square. So dear friends, what is going to happen? The relation becomes this: alpha beta, alpha multiplied by beta, alpha beta is equal to, you can see in the top part, in the numerator we have 4ac, and the denominator we have 4a square. So assuming a is not equal to 1, we are removing this. So we are having c 4a square. So a remains. So we are having c by a. So alpha beta equal to c by a. So let me summarize these two very, very important formula for your numerical, which will come in the exam on quadratic equation. So quadratic equation is of the form ax square plus bx plus c equal to 0. And we have seen in this small derivation, I derived the value that if alpha and beta are the roots, if they are the two roots of the equation, then alpha plus beta will be equal to minus b by a, and alpha beta will be equal to c by a. I will request all the students who are there to kindly keep a note of this, and I'm sure you will not forget these two relations, because these two relations will be very useful for you if you remember it in order to solve the numerical problems which we are going to now handle. So I will now move on, dear friends, to example number 6, which is going to be on quadratic equation, and we will try to solve the problems. We have already solved 5 problems on linear equation. Now we are taking up the quadratic part. One point is, please remember, we were writing this x is equal to minus b plus minus b square minus 4ac by 2a. A small point is, what happens if b square minus 4ac is 0? If it is 0, then what will happen? The roots will be real and it will be equal, because it will become minus b by 2a. This part will vanish. So if b square minus 4ac is 0, then the roots will be equal and it will definitely be real number. Okay. If b square minus 4ac is greater than 0, then the roots are real, but it will be unequal. So it will be real but unequal. And if the third possibility is, if b square minus 4ac is less than 0, then it will become imaginary. Hello, sir. Hello. Okay. ठीक है, sir. Okay. Imaginary. Okay. So now we can now see that hello, sir. Hello. 3 conditions are there. First condition number 1, if b square minus 4ac equal to 0, the roots are real and equal. If b square minus 4ac is greater than 0, that means it's a positive number, then it is real, but the roots will be unequal. And number 3, if b square minus 4ac is less than 0, then it will be imaginary roots. Fine. Now we move on to the first example, and this is example
Professor
number 6. With this knowledge, yes, sir.
Professor
Yes, sir. Yes, sir.
This b square minus 4ac is we called otherwise discriminant.
Yeah. Right.
Yeah, that point we have to give for the examination point of view.
Correct.
Can you elaborate again the discriminant if it is greater than 0, less than 0, and equal to 0? Please elaborate once again.
Yeah, if it is, yeah, definitely. So we have, if I will write the relation once again. So we have seen that x is equal to minus b plus minus square minus 4ac by 2a. Now what happens is, if b square, there can be 3 separate scenarios. Either number 1, so I'm writing in a table form. So situation number 1, situation number 2, situation number 3. Now first is, if b square minus 4ac, if b square minus 4ac equal to 0, what happens? If b square minus 4ac is greater than 0, Now in the first case, if b square minus 4ac is equal to 0, then this right hand part vanishes and therefore we have real roots and we have equal. So the roots, the type of roots will be real and it will be equal. Both will be equal. In fact, it will become like a perfect square. If b square minus 4ac is greater than 0, what will happen? It is a positive number and it will have a square root. So in that case, what will happen is it's real, but the roots are unequal. In the first case, it was real and equal. In the second scenario, it is real and unequal. And if b square minus 4ac is less than 0, as we know, it will become an imaginary number denoted by I. Okay. So this is basically what happens in case of the roots. We are taking the first example, and that is a simple one with which we start the quadratic practicals, and it is x squared minus 5x plus 6 is equal to 0. We will take number of problems, numerical problems. First we are starting example number 6 with an easy one on quadratic. So let us try to find out how to solve this. Example number 6. Okay, x squared minus 5x plus 6 without using the formula. Now this formula is sometimes what we saw, that minus b plus minus square root of b squared minus 4ac by 2a. It is sometimes referred to as Sridharacharya's formula because the well-known Indian mathematician Sridharacharya is credited of discovering this formula. Now if you see this particular question, x squared minus 5x plus 6 is 0. In this type of problems which students are getting frequently in the exam, what we do is we break it up in this way. Now 6 is 3 into 2 and again 3 plus 2 is 5. So we are using those roots because we know that alpha plus beta equal to minus b by a and alpha beta equal to c by a. So using this, if I expand this given expression, x squared minus 5x plus 6 is equal to 0. I find this x squared minus 3x minus 2x plus 6 is equal to 0. So I am breaking this minus 5 into minus 3 and minus 2. So I am getting two expressions, x squared minus 3x and I am getting minus 2x plus 6. From the first expression, x squared minus 3x, I am taking x common, so I am getting x minus 3. First expression is done. I am taking it out. Minus 2x plus 6, I am taking 2 common. So if I now write it within bracket, there will be a change of sign. It will become x minus 3. This will be equal to 0. So from this, we can get the two roots of the two equations. We are getting x minus 3 multiplied by x minus 2. This is equal to 0. So from this problem, x squared minus 5x plus 6, finally what we are getting is the solution. This will be x minus 3 into x minus 2 equal to 0, which means either x is equal to 3 or x is equal to 2. So this is how we solve this type of problem. Now we move on to the next interesting problem, and is going to be a very small, a small question, very simple question. We are going to divide. The question is, divide 25 into two parts, so that the sum of their reciprocal is 1 by 6. So the sum of the reciprocal two parts. So two parts A and B. The sum of the reciprocal will be equal to 1 by 6. Fine. So this is a case of equation. So let us do it this way. I am requesting all the students who are there to understand and practice with me. You must have kept pen and paper ready with you so that you can parallelly do the problem, solve it, and understand each and every part, because many of these problems come in the exam. We will go through another 7, 8 or 10 problems today. So we have this problem given. Divide 25 into two parts so that the sum of the reciprocal is 1 by 6. So what we do is, let one part, I am rubbing this problem. I hope the problem is clear to you. Let us go to the solution. Okay. So let 125. So let one part be x. So the other part is 25 minus x. Our objective is to break 25 into two parts so that the sum of the reciprocal is 1 by 6. Very good. Now, first part is x. The second part is 25 minus x. Question is given that the sum of the reciprocal will be 1/6. So how to convert it into equation? X, I will take the reciprocal, so it becomes 1 by x. 25 minus x, again I will take the reciprocal, so it becomes 25 minus x. 1 by x plus 1 by 25 minus x, and this is equal to 1 by 6. Dear friends, students, I have seen with my interaction when I take the classes, of course the physical classes in mathematics, statistics, logical reasoning in Eastern India Regional Council. I am from Kolkata. When I interact with the students in the class, I find that most of the students, they have difficulty in converting the given problem into the equation. So this is my only suggestion to those students is to practice a variety of problems like this, hands-on approach, step-by-step learning, so that we are able to understand the problem, understand, apply our mind, and convert the problem into an equation. So two things in mathematics. Yes, we have to remember certain formula, like we saw the case of Sridharacharya's formula. We have to remember that the sum of two roots, alpha plus beta, is minus b by a, and the product of the roots alpha beta is c by a. You have to remember. At the same time, we also need to understand how to convert the problem into an equation. If we can do it, then everything is solved. We will get full marks. So let us see. Now we work it out. We have the inverted, we have got the reciprocal. So x and 25 minus x, I take the LCM. So this becomes 25 minus x plus 25 minus x. So this is x. This is equal to 1 by 6. So this means 25 minus x and plus x cancels out. Numerator we have 25. Denominator we have 25x minus x squared. This is equal to 1 by 6. Okay. So now we go for cross multiplication. Cross multiplication. This is a fundamental thing we have learned in school. And by cross multiplying, we get 25. I'll just write it here. I'll write it here from here. So we just cross multiply and see what happens. So 25x minus x squared. This is the first part. Gives me 25 into 6, that is 150. Okay, so if I change the sign, I get x square. I take it on the other side, x square minus 25x. X square minus 25x gives me plus 150 is equal to 0. So this is the equation we get. Now, again we can see here, we have, this is of the form x square plus bx plus c, right? So this is the b part, coefficient is b. So we break it up, and if you see 150 here, 15 into 10 gives me 150, 15 plus 10 gives me 25. So I solve in this way, x square minus 15x minus 10x plus 150 is equal to 0. From here I get x square minus 15x, the first part, minus, I take 10 common from here, so 10, I get x minus 15 again, this is equal to 0. So if I solve it, now it falls in place and it becomes very simple now. So I get x minus 15 into x minus 10 is equal to 0. So x is equal to either 15 or 10. So friends, we knew that that we have to divide 25 into two parts, and the parts are 15 and 10. If I reverse it, if I add it up, 1 by 15 plus 1 by 10 will give us 1 by 6. So I think this was very interesting for many of our friends, students who are doing it for the first time. And now we go into the other type of example, and I will take up a very interesting example of a problem. Now we will take, this is number 7, example number 7 on equations. Till now we have done linear equations, we have done the quadratic part, and we will take example number 7 now. Okay. So example 7 is very interesting, like the other ones. The denominator of a fraction exceeds the numerator by 5, and if 3 is added to both, the fraction becomes 3 by 4. Fine. So denominator of a fraction exceeds the numerator by 5. So a fraction is, say, a by b. So in this case, a is the numerator and b is the denominator, and the denominator exceeds the numerator by 5. So if I assume that numerator is x, then the denominator is x plus 5. Okay, so we have x plus 5. So this is the fraction. Fine. Now the question they are saying in the numerical problem, that if 3 is added to both, so 3 is added to the numerator as well as 3 is added to the denominator, the fraction becomes equal to 3 by 4. So let us put it in the equation form. So numerator we are adding by 3. 3 is added. Very good. Denominator we already have x plus 5. Now we are adding 3 again. So x plus 5 plus 3. So this becomes 3 by 4. So let us simplify the equation. X plus 3 and denominator will be x plus 8. This is equal to 3 by 4. Now this is, friends, a linear equation. You can see that the degree is 1. We don't have to the power of 2. We don't have cubic equation. We just cross multiply and see what happens. So we have 4x plus 4 3s are 12 is equal to 3x plus 24. So by transposing this, we have 4x minus 3x is equal to 24 minus 12, which is 12. So x comes to 12. Now if x is 12, then the numerator is 12. So the denominator is x plus 5, that is 12 plus 5, which is 17. Therefore the fraction is, the question was, we have to find the fraction, and the solution is 12 by 17. The fraction is 12 by 17. This was example number 7. I hope we have done it together, and students who are following it must have understood. Now we are proceeding to example number 8. We will look at the next example, and this one also will be a very good learning experience. So I am going to example number 8 now. Example number 8. The question is like this. These are, many of these questions I'm solving are exam questions which have come in the past few years. And these are very, very important again, because similar questions might be coming in our exams as well. Now this question, let us take, if 3 times of A's age 6 years ago is subtracted from 2 times of his present age. So let the age of A is A. Fine, we take A's age is A. The question is, if 3 times of A's age 6 years ago is subtracted from 2 times of his present age. So 3 times of his age 6 years ago. Now today his age is A years, of course, in terms of years. 6 years ago his age is A minus 6. 6 years back. 3 times of his age 6 years back. So the equation is, the expression becomes 3 into A minus 6. If this is subtracted, so this is expression number 1. Very good. if this is subtracted from twice his present age, what is his present age? It is A. Twice his present age means 2A. Okay, very good. So we get second expression. The question is, if this part is subtracted from this part, that is, if we do 2 minus 1, this minus this, we will get his present age. That is, we will get A. So the equation becomes what? Very simple. So the equation becomes 2A minus this part, that is 3A plus 18 is equal to A. So I have done 2A minus 3A minus 18, minus of minus 18, so it will become plus 18 is equal to A. So therefore, by transposing, so the equation is this, 2A minus 3A plus 18 is equal to A. So if you move all the A to one side, that is A here is the variable, we move it to one side, so we get 3A plus A minus 2A equal to 18. That is 2A is 18, so A becomes 9. So his present age becomes 9. Okay, so you can see that A's present age is 9. So this is also a very typical problem, dear friends, which comes in the exam. And this was our example number 8. We have already solved 8 problems as we are moving on. And now we move to the next one. And this is a very interesting question in the area of trade and commerce, demand and supply. Okay, now this is a lovely question because it is linked with economics. And dear students, in CA Foundation, we have a paper on economics. And in economics, we have learned, as a CA student, we have learned about demand and supply. Now, let us see the question. It's a beautiful question. ICAI questions are so interesting to solve and it opens up our mind. Let us see the question. The demand of a particular commodity, that is demand of a particular commodity, is given in terms of an equation D is equal to 100 into 10 minus P. Fine. The demand equation is D is equal to 100 into 10 minus P. Right. So we know in economics, I'm just showing, of course, all of the students are aware. So normally we have the demand curve and the supply curve, it intersects. So we have demand curves and supply curves. So which means that for every, for the demand of every commodity, the demand for every service, yes, we can actually place it on a graph. If the, say for example, if the price of a bottle of cold drink is 15 rupees, what will be the demand? If the price is increased to 20 rupees, what will be the demand? If the price is reduced due to COVID and all this, if the price is reduced to 10 rupees, 11 rupees, what will be the demand? So if you plot all the price and the quantity together, you will get a demand curve. And the demand curve will have an equation like this. Very good. So the demand is given. Please note that here P means price. Later on, dear friends, I may take up another session later on functions, and then I will discuss that here demand is a function of price because the amount of price will determine the amount of demand. We know more is the price, less will be the demand normally, but for certain commodities like medicines, like chawal, rice, even if the price increases, demand will remain fairly the same. Fine. So the demand equation is given, and now the supply equation. Let us see the supply. Beautiful question. CA question. It came in the exam. The supply equation is S. S stands for supply. S is equal to 75 into P minus 3. Fine. Now, beautiful question. The question is, yes, we are given two equations. One is the demand equation, one is the supply equation. And we have to find out what is the market price and the quantity that will be bought and sold. Okay. So what will be the quantity which will be bought and sold and we have to find out the market price. Fine. So we know the demand equation, we know the supply equation. I'm just going for 30 seconds. I'm going into economics so that we understand. Okay. So we know that normally the demand equation is like this. I'm writing DD, and the supply equation is like this, SS. Okay. This intersecting point, when the demand curve and the supply curve mix, they meet, they intersect, they cross each other. That point, that price we have to find out. The price at which demand equals to supply. Okay, so a very interesting problem, dear friends. So I'm just rubbing this graph. Okay, that means we have the demand curve, we have the supply curve, we have to find out the price, and the hint is given in the question that demand should be equal to supply. That means whatever I produce will be sold. In other words, I will not have any closing stock. All my stock will be sold, friend. So what do we do? Just use, dear students, just using our brain, our normal common sense, we can understand that this is a case where we have to equate these two equations. We have to just equate them. So we are getting 100 into 10 minus P. The first equation will be equal to 75 into P minus 3. The second equation. Now if I equate it, let us work it out. So we are getting 100 into 10 minus P, that is 1000 minus 100P is equal to 75 into P minus 3. So we have 75P minus 225, because 75 into 3 is 225. Fine. So by solving it, by simplifying it, we are getting minus 175. This minus 100, this 75 comes to left hand side. Minus 175P is equal to minus 1225. This 1000, which is positive, goes to the right hand side. It becomes negative. So we get minus 1225. This means P comes to 1225 by 175, and I think it works out to 7. Yes. 175 into 7 is 1225. So P equal to 7. Right? So we have got the price is rupees 7 per kg. Now the question was that please tell us what will be the price. We have got the price and the quantity that is going to be bought and sold. So what will be the quantity which will be bought and sold? Very simple. We know the demand. Demand for the product 100 into 10 minus P. We know P is 7. So please substitute. Instead of P we will write 7. I am using red color pen. So I am writing 100 into 10 minus 7. 100 into 10 minus 7. The equation was 100 into 10 minus P. P is 7. So 100 into 10 minus 7. This gives me 100 into 10 minus 7 is 3. So I get 300 kg. 300. So in this way, we have found out what is the price at which the demand meets the supply. Number 2, we have also found out the quantity which will be purchased or sold at this particular price. Okay. Now we move on to the next example. I hope this was interesting. I am trying to give different type of examples from economics, from numbers, from different areas so that we understand and we have the interest in this particular chapter. Now we are taking another example. Yes, sir.
Professor Chakrabarti, sorry to interrupt you. The students
Yes,
were asked the page number in which you are using the example. They were they give the page number. They will be refer also simultaneously.
Okay.
They can easily understand them.
Okay. This question I'm just sharing. This is I will give them the I'll give them the page number. Okay, just a sec. Okay. This particular question, I'll give the slide number. The slide number is, this is example number 10 and the slide number is 27, sir. Sir, this is the one I just did was example number 10 and the slide number is 27, sir. Okay, this is the one we have
Okay.
done just now. Example.
Okay, sir. Go ahead, sir.
Okay.
Go ahead. Students can easily refer.
Thank you, sir.
That would be helpful for them.
Yes, sir. Yes, sir. Okay.
Fine, sir.
Okay,
Fine.
sir.
Go ahead, sir. Go ahead.
Right. Now we move on and we go to another example. So I am now going into another example. Okay, just a sec. Yes. Now I am going to example number 11 and this is number 20, example number 11 and slide number is 28. So I am also referring the slide number so that the students can easily refer to it. And the question, let us see, we will solve it. The question is, if the numerator of a fraction, so again we are having a fraction, we call it AB, A by B. If the numerator of a fraction is increased by 2 and the denominator by 1, then it will become 1. Fine. Again, if the numerator is decreased by 4 and the denominator by 2, it will become half. We have to find the fraction. So we are given two conditions, two situations. Let us try to find it out. So let us give the fraction f is equal to a by b. Fine. Now two conditions are given. This is example number 11. Just rub it out. And the slide number is 28. Okay. So, yeah. So we have the fraction a by b, and if the numerator is increased by 2, so if a will become, numerator will become a plus 2, the denominator is increased by 1, so b plus 1, okay, then this is becoming 1. First condition in the problem. Second condition, if the numerator is decreased by 4, so a minus 4, because numerator is decreased by 4 and the denominator is decreased by 2, so denominator b is decreased by 2, then the fraction becomes half, that is 1 by 2. So we are getting two equations, 1 and 2. Fine. So now we will try to solve it. We have to find the fraction. So dear friends, we are having two equations. We are having two unknowns, two variables. In this case, a and b, two variables. So let us try to solve it. Now I will just rub this part and we will carry on with the solution. Just once again I'll rub it. I am also giving the slide number, example 11, and slide number is 28. So let us solve it once again. So the first equation is, if the numerator is increased by 2, so a plus 2, denominator by 1, b plus 1 is equal to, the fraction becomes 1. And then we have, if the numerator is decreased by 4 and the denominator decreased by 2, it becomes half. So by cross multiplying we can see a plus 2 is equal to b plus 1, first equation. Okay, and from this equation, that is number 2, this is number 2 and this is number 1. So from the second equation, if we do a cross multiply, then we get 2a minus 8, 2 into a minus 2 into 4, so 2a minus 8 is equal to b minus 2. So we can see from the first equation, if we substitute, let us try by substitution. So from here we can see a is equal to b plus 1 minus 2, that is b minus 1. This is the value of a we have got. In the second equation, what have we got till now? We have got 2a minus 8 is equal to b minus 2, or in other words 2a is equal to b plus 8 minus 2, that is b plus 6. From here we are getting a is equal to b plus 6 by 2. Okay. Now we already know a is equal to b minus 1, and here we saw a is equal to b plus 6 by 2. So we just equate these two. If we equate these two, we can easily get the value of b. So the first equation we have seen a equal to b minus 1, and from the next equation we see a is equal to b plus 6 by 2. So we just equate them and see what happens. Okay. Very interesting problem, and I'm sure the students are following. So b minus 1, this b minus 1 is now equal to b plus 6 by 2. Again we cross multiply, we get 2b minus 2 is equal to b plus 6. That means b comes to 6 and 2 is 8. So we are getting b equal to 8. Now we already know that a is equal to b minus 1. So if b is 8, then a is equal to b minus 1, that is 8 minus 1, which is 7. Therefore, dear students, the fraction is a by b, and a is 7, b is 8. So the fraction f is actually 7 by 8. So this is also very interesting, and purely by using simple linear equations and simultaneous equation, we are able to solve this. Now we proceed to the next example, and I will take up the example number. Okay, let's take number 13 first. Lucky 13, it's not unlucky but lucky 13. Let us take example number 13 in the presentation, and the slide number is 31. Okay. Okay, the slide number is 31 and the example is 13. Okay. So, the 5 times of a positive whole number is 3 less than twice the square of the number. Find the number. So, once you hear it, you think in the exam condition, you're speeding up, you seeing that, oh my God, what are they asking? But in mathematics, my only suggestion, my only request, stay calm, stay cool, read the question. If not possible to understand it once, please read it once again. I'm sure you'll understand. The question is, 5 times of a positive whole number is 3 less than twice the square of the number. So let us assume the number is x. Fine. 5 times of a positive whole number. So it's a positive whole number. 5 times means 5x. Fine. Then they are saying this 5x is 3 less than twice the square of the number. So we have to find out the square. Square is x square. Twice. The problem says twice. So 2x square. Okay. So the relation becomes very simple. Now 5 times of a positive whole number is 3 less than twice the square of the number. In other words, 5 times of this number is 3 less than 2x square. In other words, 2x square is more than 5 times the number by 3. That is 2x square minus 5x is equal to 3. So we get this equation. So 2 into square of the number, 2, just using the red color, 2 into square of the number, this 5 is this 5x which has gone, and we got the difference of 3. So it is a quadratic equation. Students may kindly note that this is a quadratic equation, and the form of the equation, if you see, the form of the equation is ax square plus bx plus c. In other words, if you simplify the equation, we get excuse me, you get 2x square minus 5x minus 3 equal to 0. So let us see how to solve it. We just do this, we break it up. 2x square minus 6x plus x minus 3 equal to 0. We get 2x common from the first two expression. So we get, if you take 2x common, we get x minus 3 plus 1. Taking common, we get x minus 3 equal to 0. So therefore we have x minus 3 multiplied by 2x plus 1 equal to 0. So dear friends, please note that we are getting two values of x because it's a quadratic equation. So we are getting the values x minus 3 is 0, which means x is 3. And we are getting another value 2x plus 1 equal to 0, which means x is equal to minus half. But please remember, in the problem it is clearly given. Clearly it is given that the number is a positive whole number. Therefore, this option is not correct. Only this option is correct. X has to be equal to 3. It cannot be minus half because in the problem itself, it is clearly mentioned that it is a positive whole number. Right? So this was the example number 13. We are doing number of good questions, and I'm sure we are having better understanding of quadratic equations and linear equations. Now we move on to a more difficult one, and I am taking up now example number 12. The slide number is 29. So this is example number 12 and the slide number is 29. So students can link it. So this is a bit, I will not say it is very difficult, but it is just, thinking out of the box has to be done. We have around 10 minutes, so we will try to complete 2 more problems before completing today. So a number consists of 3 digits. So we are now dealing with 3-digit number. Up till now we have seen only single numbers and all, but fractions. But now we take 3 digits, of which the middle one is 0. So if it is like x, y, z, 3 digits, then y is not there. It is 0. Fine. And the sum of the other digit is 9. Okay. So x and z is 9. Very good. The number which is formed by interchanging the first and the third digit. Now that means if I interchange, what will happen? Z will come here. In the middle it is 0 and x will come here. So if we interchange the number, then what will happen? By interchanging the number, it is more than the original number by 297. We have to find the original number. So we are having a 3-digit number of which the middle digit is 0. It is 0. So we have x, y, z, y is 0. If x is interchanged, if x comes to the, x is here in the thousands place, if it comes to the units place, sorry, if it is in the hundreds place, if it comes to the units place, the tens place is 0, and if z goes here, then this new number will be 297 more than the original number. We have to find it. So let us take the example, since we don't have
Excuse me, sir.
anything like...
Hello, sir.
Yes, sir.
The students
Yes,
are
sir.
asking, explain how to split the middle number in the equation.
Okay, yeah, I'm coming to that. Yes. Okay. Now, since this number, you can see that since the tens number is 0, so how to find the number? So if you take the number, let us take the number as, since there is no z, I will put it in this way. I will take it as 100 x plus y. Why? Because there is nothing called tens. If it was, if you had a tens number, tens digit is 0. If the tens digit was not 0, then I would have said 100x plus 10y plus z. But since there is no intermediate digit, so we are taking it as 100x plus y, and we also know that the sum of the digits, that means x and y, the sum of the digit is given, it is 9. In the problem it is given that the sum is 9. So x plus y is equal to 9, and if we interchange, so this is the natural number which we have formed, and if we interchange, what will happen? Interchange karne se, if you interchange it, it will become 100y plus x. So it will become 100y plus x. Interchange number. And this number, 100y plus x, will be 297 more than the original number. So the equation, this is a tough one, that's why I am doing it at the end of today's class. So how to do this? I am going gradually upwards. So the equation, if you see, is 100y plus x, which is the interchange number, is equal to the original number 100x plus y plus 297. This is the equation. This is one of the toughest one in our in this particular chapter. So this is the original number, this is the interchange number, and this is the differential between the two numbers, the difference. So if we solve this particular equation, let us see if we solve this. So we have 100y plus x. 100y plus x is equal to 100x plus y. 100x plus y plus 297. So if we interchange in this way, so we will take it in 99 in this way we will do. So 100y will come to this side and 100x will come to this side. So we have 99x plus 297 is equal to 99y by transposing x and y. In other words, we are getting 99x minus 99y is equal to minus 297. If you take 99 common, because this is a large expression, we will get 99 common, we will take x minus y, and this side we have minus 3, because minus 297 divided by 99 is minus 297 by 99 gives us 3. So we have x minus y, we are getting minus 3. But we already knew in the problem it is clearly given that the sum is 9. So we know x plus y is 9. And now we know x minus y is equal to minus 3. So let us solve these two equations. So I am just bringing it here. This is also one of the toughest numericals. So we have x plus y is 9 and x minus y is equal to minus 3. So if you just add it, we are getting 2x is equal to 9 plus minus 3, which is 6. So x is equal to 3. 2x is 6, so x is equal to 3. So if the x is 3, our number was 100x plus y. We had taken the number 100x plus y. So automatically you can see if x is 3, from here y comes 9 minus 3, which is 6. So the number is x is 3 and y is 6. The original number is 100x plus y. So that means if I put x in 3 here, I get 100 into 3 plus y, and y is 6. So we get 100 into 3 plus 6, that is 300 plus 6, that is 306. So the number is 306. And this is how we solve this type of equation. We go to the last problem of today. Looking at the time, we have done number of problems. We take the last one for today. And this is, we are taking the problem number, okay. We take number 8. Let us do it together. Number 8. Okay. So, the last problem of today we are taking is number 8 and the slide is 25. So, we are doing number 8, example number 8, and the slide number is 25. With this we will be ending today's discussion. Okay, here we are getting, the problem is in front. The denominator of a fraction exceeds the numerator by 5, and if 3 is added to both, then the fraction becomes 3 by 4. So, if the fraction is a by b, and it is given that the denominator exceeds the numerator by 5, that means it becomes like this, a by a plus 5. And the question is, if 3 is added to both the numerator and denominator, then the fraction becomes 3 by 4. So, the original fraction is a by a plus 5. I am adding 3. I am adding 3 to the numerator. I am also adding 3 to the denominator. The fraction now becomes 3 by 4. This is the relation given in the problem. Okay. So, we simplify a plus 3 in the numerator In the denominator, we are getting a plus 8 equal to 3 by 4. We just do a cross multiplication. So we are getting 4a, 4 into a is 4a plus 4 into 3 is 12. This is equal to 3a, I'm doing the other side now, 3a plus 24. So we are getting 3a plus 24. So by transposing this, 4a minus 3a, we are getting 24 minus 12. So a is coming to 12. A is coming to 12. Okay. So if a comes to 12, we can understand that the fraction becomes, if a is 12, then it becomes 12 plus 5, that is 12 by 17. So friends, these are the examples, almost 10, 12 examples we have done today, and we are just wrapping up the session. So today in the first session on equations, we have discussed about, first we started with the exam strategies. We did the recap of the algebraic equations. I will request you to remember a plus b whole square, a minus b whole square, a square minus b square. Also please remember the important formula, a cube minus b cube, that is equal to a minus b into a square minus ab plus b square. Similarly, please remember a cube plus b cube formula, which is a plus b into a square minus ab plus b square. Also, please remember a plus b whole cube formula, a cube plus 3a square b plus 3ab square plus b cube. Similarly, a minus b whole cube, a cube minus 3a square b plus 3ab square minus b cube. These formula, a plus b whole square, a minus b whole square, a square minus b square, a plus b whole cube, a minus b whole cube, a cube plus b cube, a cube minus b cube. At least these 7 formula, please keep in mind. In my normal classes in EIRC, we make sure that students remember these formula, because many of them may not be coming from a science background. Maybe they are joining from a commerce background. So that is the first thing we did. Then we went into the type of equations. We discussed about linear equations, which has a power 1. We discussed about the quadratic equation. We did a very interesting question. Can you prove 1 is equal to 2? And I made use of a classic equation, but I also told you that there was a wrong step which I did, dividing by 0. That is why we are getting this weird type of results. And also thereafter we went into linear equations. We discussed a lot about simple equations. We did simultaneous linear equation. Then we went into the very important quadratic equation, where we talked about Sridharacharya's formula, x is equal to minus b plus minus b square minus 4ac square root by 2a. And I also discussed, I derived in front of you that the sum of the two roots a plus b is alpha plus beta is equal to minus b by a. And alpha beta, the product of the two roots, gives you c by a. And then we did number of problems on quadratic equation, both numerical problems as well as sums, including ratios. We did a few numbers on fractions. We did a one on economics, where we had a demand supply curve, and we also did on digits. So looking at the time, we are about to close now. So I hope that you have followed the lesson, and most importantly, you are getting the interest in mathematics. Most important thing in mathematics is, as I said, which I spoke in the beginning of today's session, please practice as much as possible, keeping in mind exam conditions. And whenever I am discussing the numericals, please refer to your PPT, and there try to work out the solution with me step by step, so that your concept is clear and you are able to solve it. I will always ask you to remember one point. If you see a ready-made solution, you will never know the steps which are important to reach the solution. The point is not to memorize solution. The point is to solve it step by step. Step by step, assumptions you take, try to understand the problem, apply your mind, prepare the equation, solve the equation. That's why deliberately in the PPT, I have not given the solution. because the purpose is to solve it here on the whiteboard in front of you, step by step, so that you can follow, you can understand, and later on you can practice at your leisure. So dear friends, it's already past 4 and we complete this session on equations. The first part, I think there may be another session on equations where we will be taking up the remaining part of equations. We will take more examples and we will also cover matrix form of solving the equations. With this, I am signing off and I request you to go through the PPT, start solving the problems. Whatever problems we did, almost 10-12 problems we have done, and please try to also do the problems from your study material, the exercises given, and if possible also from the scanner, and we will solve more such problems, and we will hope to see you very soon. I thank you for joining this session and for paying your attention and for learning together. Wish you once again very happy CA day. Thank you, sir. Thank you, Ravi, sir. And I am switching off. I am logging off for the time being. I hand over to you, sir, if you're there, sir.
Thank you very much, sir. Thank you very much.